Okay, hello everybody. Do a quick introduction. My name is Eddy Cheah, and I hope you're looking at my introduction slide. It says IceCar Developing and Deploying IoT Technology Solutions. And what I'm going to attempt to do here is to give you an idea of how this is relevant to IoT as we see it, because we are actually a company that deploys IoT solutions. And hopefully what you'll be able to take away from this talk is an idea of how a complete end-to-end IoT solution could be deployed, both from the development of the solution to its implementation, and finally, the business aspects of how you can generate revenue from this type of solution. Now, what is happening is that we have been in IoT for a number of years, but when we started, the term IoT was not quite there yet. My experience is really in IT, and what has happened is that I have some pretty disparate experiences within the IT environment, where I started off as an engineer in the oil field doing data acquisition. From there, I transitioned to manufacturing, and then I went on to do sales and marketing as a regional person. So I've got a fairly wide perspective on both the technology and the business aspects of a lot of items that is perhaps relevant to IoT as we understand it today. So what I like to do now is proceed on with the presentation, where it will be in three parts. I will introduce the iSCADA technology, which is essentially an IoT platform. Then I will introduce iBoss, which is a development we did to actually put together something in IoT that is implementable, and it replaces an existing system and introduces some innovation which brings value to the solution that existed. And finally, I will explore the business issues as to why we went into this in the very first place. Now, this is the iSCADA platform itself. As you can see, it's essentially a IoT platform in a very simplistic form, where we have developed this architecture way back in 2004. We actually conceptualized it 3 years before. Took us a while to build it, and we deployed the first system using the iSCADA platform in 2004. If you look at traditional SCADA systems, now, by the way, SCADA is supervisory control and data acquisition. We used SCADA as an example because SCADA is very, very extensively deployed. And when we looked at the situation way back 15 years ago, we kind of understood that if we were to deploy in this environment, we will probably be able to open up business opportunities in this particular area, where it was software as a service, hosted data acquisition, etc. Now, the traditional SCADA systems, when the internet came along, was basically you took the information out of the computer, and then you just linked it into the internet. Based on that type of infrastructure, we conceptualized an end-to-end solution that went from sensor all the way to a server sitting on the internet. And our users then could log into the server and look at the data coming from their sensors. So iSCADA basically was an enabling platform just to link seamlessly sensor data to a PC sitting in the office. And all this was more or less done 15 years ago. There are two components that we worked on. The first was the Internet Gateway. Today is much better understood. We would say that this will be the front end of the system. And what you see over there is a summary of what the gateway does. So essentially, it's much more developed today. And as we know in this term, Internet of Things, it's essentially a gateway that is being used to collect data from various sensors. So the gateway is where we have our link into the individual sensors, and our latest generation of gateway uses an Intel device, and it is our 4th generation gateway. Now, the gateway has two functionalities. It accepts data from virtually any sensor, low-level data, low-level signals, processes the signals, timestamps it, and then it sends it onwards to the server. We can do any level of encryption that you wish to, and we can secure the data at source or protect it at source through encryption before we send it to the server. And we can have very, very basic encryption to very, very strong encryption, depending on the usage of the data. And this is how we started and how we got through to our early implementations from the 1st to the 3rd generation platform of iSCADA. We started off using a dial-up modem, and the first server version really was browser-based, very, very simple. The second version, which we completed development in 2006, had a more advanced processor where we could accept more data, and we could also now link into a higher level communication network to link into the server in the internet. And on the hardware side, we introduced an ARM processor at that time. Then in 2010, we had our 3rd generation. So this was a vast improvement over our 2nd generation because resources were becoming available for us to expand on what we needed to do. And we realized very early on that there were only certain things that we could actually get involved in, and we needed to form a lot of partnerships in order to build the devices, write the codes, and get everything together so that we could have an end-to-end platform. Fast forward to 2012, we identified a very important project, which we have since named iBoss. And this project actually gave us some very, very clear directions as to what we wanted to do with this platform. Now, the second part of this platform, or rather, let me just conclude, the gateway can link into any type of sensor. It is a two-way device, so you can actually receive signals, low-level signals from any device, and you can also accept control signals coming from the users or coming from the server, both manual or automatic, and control the devices if there is such a facility. Now, the second part of the platform consists of our software that resides in the server in the internet. Basically, what this does is to organize the data collection, do the encryption and decryption together with the gateway, and it also controls the devices and the sensors. Because we are looking at all this data, of course, we can alert when the data reaches certain levels and all that. These are now part and parcel of the Internet of Things. And when we were developing this platform, it just seemed like the obvious things we must have in order to make sure that we can deliver the sort of value we were trying to deliver with this type of technology. And finally, we had the user interface. And what is clearly missing over here is the data analytics. Now, we do not have any particular strength in that area. That's why it's not been built into our platform. And this is the area where we are looking forward to in the near future to integrate it into the platform, possibly with partners with domain expertise in that particular area. So essentially, between the server and the user just needs to have a browser, and everything is done via the browser. So we have different modules to control different functionalities, and it's a full-fledged SCADA platform, and it has all the functionalities of any high-level SCADA system that is sitting on a PC, but in this particular case, it sits on the server. An interesting point to note over here is that we actually discovered several years ago that there was a need for us to reduce the latency of the entire process. So we have actually developed a capability where we can take the essential server functionalities and park these functionalities into the gateway. Now, this was very expensive, but from what we are looking at now and the developments that are going on, we believe that this approach could deliver some significant benefits to the entire platform, because it gives us the flexibility and the versatility to address any of the commercial situations we have been faced with in trying to deploy the iSCADA platform. The other thing that we have done is, because this is essentially a push platform as opposed to a polling system, which is normal with SCADA systems, we are now able to have a health check on the gateway device. So we have built in some fairly good functionalities into the gateway so that we can tell whether the device is functioning normally, or are there any issues with the communication, with the collection of data, or any of the other functionalities that are built into the gateway. So as a summary, this is the iSCADA platform and the technology that we have developed that supports this platform. So it is relatively mature. In its first iteration, it was deployed out there in 2003, and today we are on the 4th generation deployment. And different way to summarize the entire platform is starting from the server side, which is, I suppose you can call it the center of the system. We have the gateway on the other side, and then we use existing telecommunication infrastructure to get the data from our gateway, which is essentially the internet, into our server, and then we have a whole infrastructure to support the server, and then we have our links to our users, and then we have backups for the entire infrastructure. So this is a summary of the iSCADA system. Now, the iBoss application and the iSmart application is a development of the iSCADA platform specifically for fire safety purposes. What we did was we looked at some legacy systems, and we identified fire safety as one of the potential areas of business that we could go into, where the deployment of an iSCADA platform could bring significant benefits and advantages into this area of endeavor. So the way we designed the system was, there was already a system in place, a first generation system, to look at fire alarm systems in large buildings or large facilities. And this system was called the CMS, the Centralized Monitoring System. The functionality of this system was to connect the fire alarm panel of the building directly to the nearest fire station. And in Malaysia, our fire services is called BOMBA, B-O-M-B-A. So on the one end, you have this client-side equipment, which is the fire alarm panel. And on the other end is our BOMBA station. So everything in between was the infrastructure that needed to be replaced in order to have this particular service renewed and updated. So our proposed solution, which we called iBoss, was really an end-to-end Internet of Things platform. At the front end was a very, very simple sensor, which was the fire alarm panel. And on the other end was the fire services who could log on and have any fire signal triggered by the fire alarm panel communicated directly to the central fire monitoring location, as well as the individual fire station covering that particular building. So just a quick comparison about the differences between iBoss and the CMS. Now the CMS was implemented 20 years ago, and iBoss was implemented is still being rolled out as we speak today. More than 4,000 systems are in place, and there is a plan to have 10,000 units nationwide by the end of next year. So the whole of Malaysia will be equipped with this system. Another little way to show what the iSCADA platform is all about: linking into any sensor, going into the gateway, into the server in the internet, and then you can get reports, you can have real-time data, albeit with a bit of internet-based latency. You can generate alerts, you can provide control signals, and essentially you can do a degree of building management. What we have done with this platform is that we have made a special development where we have put together iBoss. So at the front end, the sensor is the fire alarm panel. Then we have the gateway, which we call the Fire Service Portal, the IFSP, and the platform is called iBoss. iSmart is a more advanced version of iBoss, and we developed it because there were other requirements. What the Malaysian fire services wanted was a very, very simple system that just showed them the fire alarm when it was triggered, and that was their base requirement. So once we built that, we found out that Bomba, our fire services, had other requirements which they wanted to implement. Once this base functionality was proven and it was properly integrated into their existing systems. So we decided that we will make our own investment, and we came up with an extension to iBoss, which we call iSmart. It comes in two versions. The first version gives slightly better functionalities, and it addresses the legacy fire alarm systems that are already in place and deployed throughout Malaysia, and it gives a much better spectrum of information regarding the fire sensors, the fire safety sensors, and their state of readiness and all that in existing buildings. It also tells you where the zones are, where the fire was detected, and what triggered the fire. So you get a little bit more granularity with iSmart as opposed to iBoss. Now, for present and future systems, we developed a version of iSmart that we call iSmart Comprehensive. iSmart Comprehensive will address all outputs from existing systems to be deployed systems, and what we believe will be the requirements for future systems, where we can send the location of the fire, we can tell the owner of the building and the fire services what alarms triggered, where they triggered, and these are the type of information that is needed in order to fight the fire more efficiently if that eventuality occurs. So building the system, we had to look at what were the requirements that were existing and how we could try to anticipate, how we could address emerging requirements which we could also already foresee, and also perhaps future requirements which will be nice to have for fire safety purposes. And the diagram you see in front of you is just something that we use to capture all the requirements that our fire services had in terms of what they wanted to see in a deployed system that was monitoring the existing fire alarms in buildings, and how it could be integrated with other systems that they already had specified and were being put in place to address other issues. So a quick comparison between the iBoss solution and iSmart as to what it could do in addition to iBoss. Now, iBoss by itself was merely a replacement for a first generation fire alarm system. iSmart, in contrast, is a more advanced system with much better functionalities. So how does the system operate? Well, I'll just let the slide run through. A fire alarm is triggered, the event is transmitted, and it goes to the building owners and to the fire services. The whole system is backed up, and then we have 24/7 technical support because it needs to be a high resilience system. At the building level, the building management has to nominate a safety officer and somebody else, 2 personnel. So when their fire alarm triggers, the signal goes to the IFSP, where it will then go into the backend cloud server. And Bomba is not the first people who will be informed. It will be the building owners. Now, why we do it this way is to mitigate false alarms, because that was one of the major problems that occurred with the existing system. The building owners will get an SMS, and this is the nature of the SMS. They get all the telephone numbers for the fire services. Okay, people, again, we had another problem with our connection, but I'm coming to the end of my presentation. Just for anybody who's interested, there is a white paper on the Intel website on this project. It takes you through the entire program. And what you will take out of it is how the program was conceived, conceptualized, the business case, the business model. If you look at the white paper, at the end of the white paper, there's also another paper that we wrote up, essentially in support of the white paper, to provide details of how the entire system was put together. Okay, there's a question here, how data backup can be handled when internet server is down, while in case of fire with iBoss alarm management. We have never experienced this problem because of the backup we have on our server end. And also, a lot of these installations are manned. So if the device is down, we will know about it. And then there are also manual overrides or manual backups. So that is why it is just data backup. Let me read the question again. How data backup can be handled when internet server is down while in case of fire with iBoss alarm management? No, there's no iBoss alarm management per se. We have a backup server and we have a server management system. So we will be able to switch to the backup, and we have continuous monitoring 24/7 of the health of the entire system down to the individual gateway level. So this has not happened before, and we have managed to catch every situation where we have encountered a failure, an individual device failure, and had it rectified. And remember, we have well over 4,000 systems already in place. Now, like I said, I will put the link to the white paper, and then you will be able to get as much information as you will possibly need from this. session, and I hope that all of you have managed to get something out of it which is useful to you. Thank you very much.